And good morning, math masters and math wizards. Hope you had a good night's sleep. You're enjoying your day in the sun, beautiful weather. You can get out your problem set 16, and this is page 168 for those of you that have them. If not, we can still do this together with scratch paper, so you want to get a scratch paper and pencil. And we'll look at 4. It says solve, write the sum in unit form. Okay, in unit form. So, kind of like what we did yesterday. I'll take it nice and slow. We have 2/4. Plus 1/4. What is that going to equal? I know some of you say, well, I already know. But let's go ahead and do a tape diagram to really show what it's all about. We have 2/4. So I'm going to break this into 4. This tape diagram is 1. So we have 2/4. 1 and 2. Then we're going to add on one more 4th, right? So what do we have? 1, 2, 3/4. And let's look at 4b. It says 4/5 plus, how many fifths is that? 3/5. 4/5 plus 3/5. I think this is going to be greater than 1, don't you? Well, let's find out. Let's do 4/5. 1, 2, 3, 4, and 5. And we'll do 4/5. Ready? 1, 2, 3, 4. There's 4/5. This represents 1 whole. So if we add on 3/5, we can see that it's going to be more than just the 4th, than just 1, right? So I'm going to do another tape diagram. And we'll put these in fifths. 1, 2, 3, 4, and 5. And we're going to add on another 3/5. So I'll use a different color. You could just use your regular pencil, but 1, 2, and 3. So what do we have here? We have 1, 2, 3, 4, 5/5. 6/5, 7/5. So 4/5 plus 3/5 equals 7/5. Okay? And if we want to turn this into a mixed number, we could say we have 1 whole and 2/5. And there we have it. All right, let's go to number 5, and this is 5a. And boy, Mr. Larry does need those glasses. It's 2/8 plus 5/8. And this one we're just going to solve. We're not going to draw the tape diagram. We're not going to write it in uniform. We're going to write it as a fraction. And remember, on the denominators, they do not change. They do not change. They will not change no matter what you do. So it's not 8 plus 8 equals 16. It just stays 8. But the numerators, the number on top of the fraction bar, 2 plus 5, we do add those in 5, 6, 7. So we get 7/8. But we do not add those. Let's look at the next one for 5b. And it is 9/12, I hope. No, 4/12 plus 5/12. I love Eureka math, I just wish they would write a little bigger. Alright, so 4/12 plus 5/12, what do we get? Well, remember, do not change. They won't change no matter how much you get them, try to make them change right now. They're going to stay 12ths. And 4 plus 5 is 9. And there we have it, 9/12. Okay, let's go to our next set of problems. So it's problem 6. It says solve. Use a number bond to decompose the sum. Record your final answer as a mixed number problem A has been completed for you. Well, for those of you that don't have the problem set at home, and that's a lot of you, I understand, we'll do problem 6A, okay? So what we have going on in 6A is 3/5 plus 4/5. Once again, denominator doesn't change, so it stays fifths. Then we add 3 plus 4 and we get 7/5. Now remember, like we did yesterday with the number bonds, we're going to do that again. So this becomes 5/5 to show 1 whole. And how many fifths do we have left over? If we take 5 from there, we'd have 2/5. So what would this equal? We have 1 whole plus 2/5. So we have the 1 and 2/5. And we get that mixed up number, as it says on the video we watched yesterday. All right, let's continue on with B. And B is, boy, it's getting bad, kids. 4/4 plus 3/4. I hope that's right. So what are we going to get from this? Well, put our fraction bar there. The 4's don't change. And 4 plus 3 is 7, so we have 7/4. Now, we got to get our 1 done. Remember, 1 would be equal numerator and denominator. 1 whole, so we'd have 4/4. But what do we have left over? 7 minus 4 is 3, right? So we would have 3/4. And what will we get? It would equal 1 and 3/4. There we have it. Let's go to problem C. 6/9 plus 6/9. What do we get when we do 6/9 plus 6/9? Well, remember, the 9, the denominator, doesn't change. But we do add the numerators. 6 plus 6, or 6 times 2, is 12. And we get 12/9. What is this going to equal? Let's break them apart. We'll do 9/9 to show 1 whole, right? Because remember, an improper fraction is always greater than 1. And improper, remember, is when the numerator is larger than the denominator, just like the video. Maybe I'll assign that video again for you to watch. So we'd have 12 minus 9 would be 3/9, right? There's our 9/9 plus 3/9 equals 12/9. So we have 1 whole and 3/9. All right, let's keep on moving right along to problem D, which is 7/10 plus 6/10. Now remember, the 10th doesn't change. But 7 plus 6, we have 7, 8, 9, 10, 11, 12, 13. We have 13/10, and we need to break this apart. Mr. Leggett has some pens coming too. So we'll have some nice new pens to work with. We have 10/10. And how many do we have left over to make 13/10? 13 minus 10 is 3. So you'd have 3/10. So we have 1 whole and 3/10. And let's go ahead and do E, for those of you with a problem set at home. We have 5/6 plus, remember, you can always pause this if I'm going too fast. 5/6 plus 7/6, okay? So this is going to equal, 6 stays the same, then 5 plus 7 is 12, right? So we have 12/6. This is going to be an interesting one. People at Eureka are being kind of tricky here. Maybe you can already see what's going to happen. We have to do 6/6, right? But how many is left over? 12 minus 6 is what? 6/6. So we have 1 whole plus 1 whole. Well, what's 1 whole plus 1 whole? Or 1 plus 1. Learned that back in kindergarten. 1 plus 1 would equal 2. And for those of you thinking like, I'm starting to understand that fractions are division. Take a look. 12 divided by 6 equals 2. So fractions, yes, are division. We'll go into that more later on. Let's do F. And it's 9/8 plus 5/8. Once again, what do? 8 The eighths stay the same. And then 9 plus 5, 9, 10, 11, 12, 13, 14. We'll break this apart on a number bond. 8 eighths. And then we have 14 minus 8 is 6, right? 6 eighths. So we have 1 whole and 6 eighths. And there's our answer. Okay, time to do number 7. Like I said, if I'm going too fast, you can always pause the video. No crime in that. And 7 says, solve, use a number line to model your answer. So we're going to use a number line to model our answer. So I'm going to turn the paper this way, my scratch paper. And we have 7/4 minus 5/4. So I'm going to write that up here. 7/4 minus 5/4. What will that equal? Now some of you are like, well, I know it. It's going to be fourths, and 7 minus 5 is 2. But we're going to prove this using a number line. Okay. So let's start out with 0. And then we're going to do 1 right here in the middle. And then 2 all the way over here. So there's our number line. 0, 1, 2. What are we breaking them into? We're breaking them into fourths. 1/4, 2/4, 3/4, 4/4. 5/4, 6/4, 7/4, 8/4. Okay? Let's just go ahead and label those so we really understand what's going on here. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4 are 2 holes. So we're starting out at 7/4, right? So I'm going to put a big dot right there. And we're subtracting 5/4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5/4. Boo! What do we wind up with? We wind up with 2/4. Okay, let's do the next one. And we have 5/4 plus 2/4. Okay, great. We can make the exact same number line. 5/4 plus 2/4. What will that equal? Now I know some of you, or probably all of you, are saying, Mr. Leggett, why don't we just like do fourths and have it 7/4? So that's what it's going to equal. But let's prove it using a number line. 0, 1, and 2. Let's break them into fourths. 1, 2, 3/4, 4/4 are 1 whole. 5/4, 6/4, 7/4 are 8/4, which would be 2. I'm not going to label these. Let's just give it our best shot. We're going to start up with 5/4. 1, 2, 3, 4/4, 5/4. We're going to add on 2/4. 1/4, 2/4. Boo! And there we have it. Let's see what we get. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. And what would that equal in a mixed number? Well, watch the beauty here. 1 and 1/4, 1 and 2/4, 1 and 3/4. Wasn't that great? All right, we will move on to language arts. So take out your text for close reading if you have it. If you don't, certainly just follow along and enjoy the story, or whatever it is we're going to be doing. And make sure you get in your 25 minutes of IXL math and Imagine Learning. Thank you for joining me.